OMP Routes. Every Cisco vEdge router will advertise prefixes learned at the local site as OMP Routes vRoutes to the vSmart controllers. OMP can import reachability information from traditional protocols such as EIGRP, OSPF, and BGP, and can also advertise connected and static routes. The OMP route updates are very similar to traditional routing updates. However, the main difference is that the next hop of a vRoute points to a TLOC route. In BGP, a route is invalid if the next hop IP address is not resolved in the routing table. In OMP, if a vRoute has a next hop TLOC that cannot be resolved in the TLOC route table, it is marked as invalid, similarly to BGP. In figure, for example, vEdge 1 is directly connected to subnet 1.1.1.0.24 in VPN 1 and has two transport interfaces marked with colors BIS Internet and MPLS TLOCs T1 and T2. The router will advertise to the controller that 1.1.1.0.24 is reachable in VPN 1 via TLOCs T1 and T2. This advertisement is carried in an OMP update message as a vRoute. On the other side, vEdge 2 imports the reachability information learned via OSPF in VPN 1 and advertises that subnet 2.2.0.24 is reachable in VPN 1 via TLOCs T3 and T4. vRoutes consists of a lot of attributes in addition to the reachability information. Let's list each attribute with a short description. VPN. Every OMP route is associated with a VPN, and every Cisco SD-WAN device keeps a separate routing table for each VPN. This allows for the use of overlapping subnet ranges, provided they are in different VPNs. In the example above, both subnets 1.1.1.0.24 and 2.2.2.0.24 are associated with VPN 1 and will only be reachable in that network segment, Originator. This is the system IP of the router from which the route was originally learned from. In our example for prefix 1.1.1.0.24, this value would be the system IP of vEdge 1, TLOC. This is the next hop identifier of the OMP route. Note in the example that vEdge 1 advertises two routes for prefix 1.1.1.0.24, one via TLOC T1 and one via TLOC T2. This tells the vSmart controller and, subsequently, all remote WAN edge routers that to reach subnet 1.1.1.0.24, they must have an active overlay tunnel to either TLOC T1 or T2. Active means that the BFED status associated with that tunnel must be in up state. Site ID. The site ID plays a similar role to a BGP as number. It is primarily used for loop prevention. All sites should have a unique site ID, and all devices at the same location should have the same site ID. In the example above, the site ID for prefix 1.1.1.0.24 would be 1, Origin Protocol. This is the original protocol from which the vEdge router has learned the routing information. It may be a connected interface, static route, or any existing dynamic routing protocols such as OSPF, EIGRP, or BGP. In the example for prefix 1.1.1.0.24 via T1, the Origin Proto will be connected and OSPF for 2.2.2.0.24. Origin metric. OMP includes the original metric value alongside the Origin protocol. These values are then used in the best path algorithm when OMP calculates the most optimal routes toward destinations. In the example for prefix 1.1.1.0.24 via T1, the origin metric will be 0. Preference. This attribute is also referred to as OMP preference or vRoute preference, so it is not confused with the TLOC preference attribute in the TLOC routes. The OMP preference is used for influencing the OMP best path selection for a given vRoute. Higher is better. In the example above, if we'd like to manipulate the overlay routing in such a way so that the traffic towards 1.1.1.0.24 always comes through the MPLS cloud, we can just set a higher OMP preference value to vRoute 1.1.1.0.24 via T2. The OMP preference operates very similarly to local preference in BGP. Tag. This is similar to the route tags in traditional routing. Once a value is set, it is a transitive attribute that can be acted upon via policy. A real example of a single vRoute can be seen in the output as shown. OMP, as most traditional routing protocols, only advertises the best vRoute or vRoutes if there are multiple equal cost ones. Logically, invalid vRoutes having unresolved TLOC next hop are not advertised, even if they have the best attributes.